So before, if you think about yesterday and the other stuff that we did before, I guess days before, was area. And if you remember, that was length and width. Remember that? And it also means square area. If you look at this, that's 2 dimensions, I guess 2D. Make sure you understand that. 2 dimensions, length, width. Today when we come to volume, I want you to look at this one, and it's going to be this now. Length, width, and height. For the answers in this one, it was like inches squared. For the answers in this one, well, you multiplied it. Imagine this, inch here, and inch here. That'd be inch cubed. So there's a difference between the area and volume. So you kind of read the question, determine if I'm talking about area, boom, inch squared. If I'm talking about volume, cubic stuff. Now I'm going to step off real quick. This is what you need to think. A for area, okay? V for volume. When they, I guess when these questions come out in your STAR test, they're not going to tell you, hey, find the area. They're not going to tell you, hey, find the volume. You need to determine which one they're asking. This is how easy it is, in my opinion, I think. So get like a bucket of paint, right? And if you were to pour it on here, what would happen to the A? If you were to pour it on this A for area, remember this is A for area, what would it do? It would just roll down the sides. And it would just cover. Are you all there? Is my mic muted or what's going on? Are you all still asleep? You still asleep? Okay, well wake up, right? So for the area, the bucket of paint, when I pour it out, would cover the sides. You understand that? Okay, pretty cool. So that's like a flat. That's 2D. When you pour it into the V, just think about this one. Well, it's not going to run out. It's going to like, what would it do in here? It would like pool up, right? It would like gather like a cup. So this one, this here is filling it in. This one here is like a pool, a cup, an aquarium, something that you can pour something into, if that makes sense. So you got to kind of look at the difference. Oh, are they trying to cover it, or are they trying to fill it up with something? What could you fill stuff up with? Water. You understand that? You can put cereals inside it. You can put ice, milk, whatever you want, sand, anything you want to put inside there. Well, on the outside of this stuff, you would cover it with what? Paper, paint, stuff like that. Whatever. Okay? So just come back and let's go back and just kind of always go off of that idea. Let's come over here. Okay. So identify three-dimensional figures. Okay, so you're going to be responsible for that. You're going to have to know which figure is given to you, and then after all that, then you apply what they're asking you to do. A solid with all flat surfaces that enclose a single region of space is called a polyhedron. So that's like a cube, a rectangular prism. This one I have no idea what that's called. Anybody know what that is? It's a prism, right? It's a trapezoidal prism. We'll go back to that, how to name it later. Each flat surface or face is a polygon. So with this enclosed space, every side, every face is some kind of polygon. Some kind of like this front part right here, you can see it as a trapezoid. The top part would be a rectangle, that side, rectangle, rectangle, rectangle. So they're kind of like common polygons. The line segments where the faces intersect are called edges. So along this right here, these corners are edges. The whole thing is a face. The point where three or more edges intersect is called a vertex. So like the corners are called vertex. Below are examples of definitions of polyhedrons and other types. Okay, so do me a favor. Man. I guess just write 3D figures. You're responsible for this. Each flat surface is a face. The line segments where the faces intersect are called edges. The point where three or more intersect is called a vertex. Okay? So we're in geometry, so you're going to get like harder questions, but when it comes to this is 8th grade, guys. This comes back to 8th grade. So if you noticed last year in algebra, we didn't really have many of these problems, but we did. I threw some in there, right? But this is more 8th grade stuff. So at the end of the year, you're going to be responsible for this on your STAR test, 8th grade, and then your end of course geometry, okay? So you got to be ready for both. I'm just going to basically keep it spiraled in for the rest of the year. Randomly throw in, hey, find the surface area. Randomly throw in, hey, find the volume. Find the, lateral surface area. Find this stuff, find that. Maybe numbers, maybe, I don't know, expressions with X's and Y's. Either way, you're responsible. Okay, let's do it to it. Okay, so types of solids. These are the types of solids y'all going to deal with. There's other ones, but we're just going to go with these real simple ones. So a prism is a polyhedron with two parallel congruent faces called bases. So if you look at this one right here, you see that top pentagon? It's parallel with the bottom pentagon. And each base is connected with parallelogram faces. So each base, now if you look at this side right here, this side right here, this side here, they're all parallelograms, okay? So basically like rectangle kind of radius. So write that definition down, fast, fast, fast. Polyhedron, a prism is a, how about this, is with two parallel congruent faces called bases. So in case you all remembered, I think it was Wednesday and Thursday, I talked about the base, or actually about area, perimeter. This right here is known as your big B or your big P in your formulas. Make sure you know that. This is your, in formulas, your bases are known as big B and big P. Big B stands for area of your base. The big P stands for perimeter of the base. Okay? Make sure you know that. Write that in there too. You're responsible for that. You need to know that. That right there, that's where a lot of people get messed up. So I don't understand where you're getting this formula from. Well, you're going to refer back to yesterday's notes and the day before notes. Okay, a cone. Let's go on the cone. Oh, I'm sorry, a pyramid. A pyramid is a polyhedron that has a polygonal base and three or more triangular faces that meet at one common vertex. So basically, it's going to be some kind of base, any kind of base you want, and now they all go and meet at one point. See that? The side faces are all triangles, okay? The side faces are all triangles. So make sure you know polyhedrons are made of polygons. Polygon. Okay, let's move it up pretty darn soon, or what? Y'all ready? Let's do it to it. Okay. Not polyhedrons, but you're still responsible for them. Okay, so remember, polyhedrons are made up of polygons, okay, like straight edge stuff. You see how there's no straight edge here on the circle? So it's not a polyhedron, but it's the same idea. A cylinder is a solid with a congruent parallel circular base connected by a curved flat surface. So that one, you should know that. You can just draw that. A cone is this right here. It's a solid with a circular base connected by a curved surface to a single vertex. You can draw that. A sphere, you can draw that. I won't take too much time here. Copy that figures down real fast. Definitions is not too important. But please look at the bases as far as when it comes to the cylinder and the cone. I'm going to just throw this in there real quick. This one here has 1/3 volume of that. Just draw the picture. Y'all know what a cone is. Just draw the picture. The cone, draw the picture. Sphere, I don't know how you want to draw a sphere. That one's kind of difficult. I just draw a circle going like this, like an oval this way, and then connect it with a circle going over. That's all I do. It's not the prettiest thing, but to me, I know what I'm trying to draw. Okay? Let's move it up. Polyhedrons or polyhedra are named by the shape of their bases. So look at this one. Remember, by definition, the polyhedrons are basically where the base, right, is parallel to the other base. So the things that are parallel to each other is what you name triangular prism. See the bases, the ones that's parallel? Well, what do you mean? Kind of look at it like this, guys, and it's really, that's what you need to look at. This triangle in space is parallel to that triangle. So that's your base. You understand that? It doesn't matter what they do with that thing. What do you mean, sir? Well, just I'm going to take time to do this. It doesn't matter where or how they do this. So say this thing is given to you like that. There, it's given to you like that. But what if they rotate it? You still need to identify as those bases as the triangles. Okay? Simple as that, pretty easy. How was it? Scottish. Okay, look at this one right here. When it comes to rectangular prism, okay, it's called a rectangular prism because this here is a base and that there is your base. Sure, but couldn't these be your bases too? This one here and this one here? Yes. Couldn't the front and the back be your base? Yes. So the rectangular prism's kind of like, choose a base, it doesn't matter. Usually on your star test questions, they'll put like the base darker. Okay, so you know that's your base. Going once, going twice? Okay. So looking at this one real quick, that was the example up there. Now look at that base down there. It's one-sided, two-sided, three-sided, four-sided, five-sided. So it's a pentagon. You see how it's parallel to this other one? So it's pentagonal prism. It's a prism, guys, because it's parallel to each other. This top base is parallel to the bottom base. Now this one over here, look at this one right here. This one has one base, and it goes to one point. Pyramid. That is my base, triangular pyramid. Okay? Same thing here. What's my base? That's my base, and it goes to one point. That's a pyramid. What kind of base is this? Rectangle? So rectangular pyramid. So this one over here, 1, 2, 3, 4, 5 sides. So that's my base, a pentagonal, and it comes to one place over there. So it's a pentagonal pyramid. Not too bad, right? Pretty easy. You may get lost there. If you not know what's going on, it's Friday. I know. Thank God. Okay, next page. We survived the week. Okay, so what kind of figure is this? We're going to determine whether each saw is a polyhedron. Now, a polyhedron was, I guess, like an enclosed figure with polygons. Okay? Okay, then identify the solids. If it is a polyhedron, name the bases, faces, edges, and vertices. What in the world? Okay, so let's do that real quick. So regarding this one real quick, this is it a polyhedron, yes or no? Or look at all the faces, okay? Are all the faces polygons? Now, maybe you say yes. So it is what? polyhedron. Cha-ching. What are, what are my bases in this situation? If you don't mind, I'm going to go with this one down here, that big one. So that is one base. It's parallel to this top base up here. So that's going to be my defining, leading term. So it's a rectangular, and it's parallel to the other one, prism. Not too bad, right? So let's name our bases. Our bases would be that bottom one, M, N, O, P. So we can kind of be uniform together, go in alphabetical order, okay? You understand that? And then you do name it like a rectangle, go around in a single direction. Now the top base would be this top base over here. Now what name is that one? And actually, so they put this there if you look at that. That means like a rectangle. Rectangle with M, N, O, P. So the top one is a rectangle R, S, T, Q. R, S, T, Q. There it is. Those are my bases. Next thing is, name the faces. Okay, so you got to think about that. The base is still a face. Does that make sense? So we need to name all the faces. So look, this base and this base are here listed as a face. Okay, the faces are the outside, the tangent, the stuff you can touch, I guess, if that was like a real box. Then name the other ones. Let's look, the front one. Let me see. I don't even know this one. O, P, Q, T. Let me see. O, P, Q. So there's that one. Let's name the back one over here. Where is that? R, M, N, S, R. Let me see how they named it here. N, M, S, R. So it's going to be this one here. I guess we need to name this, side front one. R, M, P, Q, or was it P, Q, R, M? Or M, P, I don't know, one of those four. I didn't know my alphabet. Would it be M, N, M, P, Q, R? M, P, Q. It went the exact opposite of me. And then this back one over here, S, N, O, T, S, N. Let me see where they put it. Well, it's going to be that one. Boom. So there are my 6 faces. Okay. Now edges. Woo! Vaya con Dios. Don't get lost on this one. Okay. So the edges now are each one of these things individually. You got it? RS. Let me see RS. QT or TQ. PO. Oh, where is that? OP. MN, you don't see MN, there it is. MP, PM, NO, no, or on, no. Which ones am I missing? This one here, QP, this one here, TO, SN, RM. Am I missing one? Oh, this one right here, ST. Okay, there are all my, edges. So name edges and do all that. The next thing, your vertices. Where are my vertices? My vertices are the corners, right? These little corners. That's it. Name those. M, N, O, P, Q, R, S, T. M, N, O, P, Q, R, S, T. There it is. Going once, going twice. Any questions there? Good Lord. Okay, listen real quick. Remember, the question is it a polyhedron? Okay, if it is, identify all the faces, all bases, faces, edges, all that good stuff. Is this a polyhedron? No. What is that one called? A cylinder. It's not a polyhedron because it doesn't have straight edges. It has these curved edges. So, ouch. Okay, the bases, in this situation, the bases would be the circles. Okay, just FYI, make sure you know this is your base, the circles. what is the distance from base to base? Do y'all know what the distance from base to base is called? The height, okay? From a base to base, that's called your height. So let me go back over there, I guess. So imagine this being your base, right? The top one. And the bottom one, that's your base. This distance from base to base is known as your height. Make sure you know that already. Going on. Okay, next one right here. Is this a polyhedron? Great. Yes, no, maybe so. What do y'all think? Well, all the faces are what? Polygons? So I'm going to say yes. I'm going to say yes. It is a polyhedron. What kind is it? What is this one? Oh, great. What is this one called? Well, it has a base here and it goes to one point. It's a pyramid. What is my base? Triangular pyramid. But boom. Next thing is let's name the base. Okay, in this situation, base. It's that bottom one, right? Triangle ABC. There it is. Name all the faces. The faces are everything you can touch, okay? All the sides, the bottom, everything. So triangle ABC there. You see the bottom one? Then they went ADC, ADC, then CDB. Then the back one way over there, you can look at that one as BD. Okay. There are all my faces. Name all the edges. Okay, so the edges, don't forget that one, are all these lines. So you can go with the back one, A, B, B, C, C, A, and then all the ones coming up. We'll go with what? D, A, D, B, and D, C. And there are all the edges. Vertices, just A, B, C, D, and there we are. Do you have any questions over this one, guys? Yes, no, maybe so? Good Lord. Let's try this one. Do we try this one or not? Okay, let's do 1A, guys. 1A. Yeah, 1A. Okay. Okay, this will be 1A. For it to be 1A, you have to determine is it a polyhedra. I think that's the way it's spelled. Okay, no. Polyhedron. And then if so, then name it. And then we're going to come out here and faces, edges, and vertices. Okay, so is it a polyhedron? What do y'all think? No. What is it? Let's just name it shape for real. What is that shape?
A cone.
Yes, this one is a cone. Jocelyn is awake. Yep, yep. Eileen, good job. Samantha, good job. Here we go, right? 1B it. Via con Dios. Oh, great. Ah! This one's going to drive me crazy now. Okay, so if we look at this one real quick, we're going to have 1B. Now, regarding that one, that's, is it a polyhedron? What do y'all think?
I think so.
Why is it? I see yes, yes, and I hear I think. Bad answer, bad answer. Because it has bases, not so much. Good, because it's enclosed by polygons. Yeah? It's all a polygon. Every face is a polygon. It's enclosed. Perfect. Good job, David. Okay, so this one, yes, it is. Yes. And then what is it? What kind of thing is it? Okay, the bases. What are my bases? Okay, so it's going to be, anybody know what it is?
Triangular.
Good job, ma'am. Triangular prism. Now, the prism, why is it a prism? Because this base is parallel to that base. What kind of bases are they? Triangulars, or triangles, triangulars. Horrible. Okay, let me name it. Okay, what are, oh, wait, we forgot bases. What are my bases? Let's figure out, what are my bases? Triangle GHI, is that okay? And triangle JKL. The bases are the ones that are parallel to each other. Okay, if you look at this, I guess, side right here, that's not parallel to anything, is it? No. So that's not your base. The only ones I can see parallel to each other are those triangles. So that's what gives me my name, triangle. Angular prism. Forgot the N. I think that's right. I don't even know anymore. Okay, let's come out here with your faces. When it comes to your faces, we are going to include the bases. We have to include the bases. So we're going to go triangle GHI, triangle JKL, and then we have to name every side, okay, as far as the base is connected to another base with these parallelograms. We name the parallelograms, and this one happens to be, we'll go with rectangle, what, we'll go HKLI. Okay, and then the other rectangle, I guess I'll do the one in the back over here. GHKJ. And then the bottom one, the way bottom one right here, would be rectangle, I guess, GJIL. Okay, now we're going to name the edges. What are my edges here? Okay, so the edges are all these lines. So basically you have to name the triangle edges, and then the other triangle edges, and then the edges that are, you know, the parallelograms that are connecting the bases, I'll name those. So I'll go with line segment GH, line segment HI, line segment IG. Then I'll name the other base over there in the back. Line segment, I'll do the same order, JK, 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 back there. KL, JK, KL, and LJ. And then I'll just name these that connect the bases. GJ, line segment, GJ, line segment, IL, and line segment, HK. Well, boom! I think we did pretty good. Nobody's freaking out, right? Nobody's freaking out yet? Good job. Don't freak out. Wait till the next section. Then we'll come out here with the vertices. Vertices would be what? G, H, I, J, K, L. I think that's it. I think we named it all. Okay, do you have any questions over this madness? No? All right, let's do it. Thank you, David. Thank you for giving me some. Daniela, good job. Eileen, thank you so much, guys. Let's go. Okay, so a polyhedron is a regular. What does the word regular mean last time? Do you remember what it meant, regular? And remember, we talked about it last section. This is 1/7 and 1/6. All sides the same, all angles the same, all that stuff is the same, basically. Remember that. So a regular polyhedron is, okay. Let me move this out of the way. A polyhedron is a regular polyhedron if all the faces are regular congruent polygons and all the edges are congruent. Make sense? Kind of stay the same, right? There are exactly 5 types of regular polyhedrons called Platonic solids because Plato used them extensively. Plato's some old dude. Old dead dude. Okay, so what in the world? I'm not even trying to say these things. I might even hurt my tongue. Anybody can say that one? Tetrahedron? How about that, yeah? Tetrahedron. Okay. What about this one right here? This is a cube, guys. Hexahedron or cube? I'll stick with cube. I don't even know what this one is. Octahedron?
It's an
Okay, good morning. Okay, well, do you know what this one is? Don't even say it. Don't say it. Okay, so those are pretty cool ones. Let's go ahead and copy down this one, the icosahedron. Icosahedron. Draw this one, guys. Draw this one, and then, but please make sure that you draw it to scale really good. Okay, I'm joking. There's no way. That's why we're going to just talk about that and move on. This is what I wanted to get to here today. Okay, please pay attention to this one. Surface area. Do you see the word area? Make sure you understand. When you hear the word surface area, we are talking about, I'm going to go back to this thing right here. Area. Pour the paint on it, right? It's going to run off and just cover the outside. Volume. If you pour paint on that one, it'll fill it up. So you're going to kind of identify these and then use the formulas that you need. So surface area is a two-dimensional measurement of the surface of a solid figure. So what's the surface? You all know what the surface is? The outside. Okay? So like the outside of the figure. So surface area, think about that. What could you do with a, we'll go with a prism. Let's go with this prism. Let's look at this box. Okay, humor me, there's a box, a prism. What could you do with it? Surface area, you could wrap it like a present. You could paint it. Surface area, surface area. Just FYI, the new type of question that's coming out, you could actually construct the box. You see how that's only the outside? How much material needed to build this box? How much cardboard? How much plywood? Whatever. Surface area. Now, what could you do with that box now? Well, you could have put a gift in there, right? You could put sand in there. You can go ahead, imagine that a fish tank. You could wrap the fish tank up. But now when you fill it up with water, volume. So you got to kind of read the question, see what's going on, and then you'll just, okay, now once you get that in your mind, then you can come on and do this stuff. It's pretty easy. It's not too hard, but it's a lot of little steps. Okay, so surface area is a two-dimensional measurement of the surface, that's the outside of a figure. The surface area of a polyhedron is the sum of all the areas of each face. So really, you do not need to know the formulas except for when you come to these. Because, well, sometimes, well, I forget where the pi is, I forget where the square is. The formula is given to you. But here, can't you identify each face? Oh, it's a rectangle, 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 rectangle. Oh, I can do that individually, add them up. You can use a formula, whatever you want. In a pyramid, you can figure out the base, oh, the area of that one, and then each side triangle, add those up, then you get the total surface area. So you got to kind of just use a formula to your advantage, or if not, use your brain and figure out, oh, each face, so it's the sum. Volume, on the other hand, is a measurement of the amount of space enclosed by the solid figure. Okay. Here we go. Copy these down. Viacom Dios. Copy that down. I'll give you 5 good minutes. Oh, Lordy, what in the world's going on? And we're going to work on some of these. What are you doing? Let's do it. Alessandra, what in the world is that? Okay, you all ready or not? What do you think? Yes, no, maybe so, kinda? Okay, Diego. Guys, y'all behave, be nice to each other, especially Jocelyn. Rude. Okay, Jocelyn, behave. Let's go, right? Okay, well, a while ago I told y'all the big P and the big B refer to the base. They're really strictly talking about the base. Don't worry about anything else, okay? So the surface area stands for P. Okay, what does P stand for? I told you about that. P stands for the perimeter of the base. You see this? That's the perimeter. Do you know how to get the perimeter of a rectangle? Yes. You know how to get the perimeter of a polygon? Just add up the distance around it times the height. Okay, so I'm going to tell you what that does. When you do this real quick, okay, so if I come out here, this perimeter, humor me, okay? Just humor me. This, imagine it like this. Imagine a box. I'm opening up a box. And this one is longer, right? So I'll draw it longer. Imagine I got the box and opened it up. This side here is that one right there. This back side would be that one. Okay, y'all see it? That base, that's my perimeter going all the way around. This height is now this. Y'all have seen that? Can y'all see that? Yes, no, maybe so? When I multiply the perimeter times the height, I figure out the area of this. What in the world did I just figure out here? I figured out the area of all the sides. I have not figured out the area of the base. I have not figured out the area of the bottom one or the top one. Okay, do you understand what I'm saying there? Kind of messy looking, but imagine the top knot and the bottom knot filled in, and it's just strictly the sides. That's what that does. Okay, that is called your lateral surface area. That is 8th grade material, lateral, okay? When it comes to your 2B, well, when I came out here and I basically multiplied the perimeter times the height, I covered all the sides. This is all your sides. Now I need to add the what? The top base and then the bottom base. That 2B. What does the B stand for? The area of the base. So I get the area of the base, which is going to be, if you think about that, how do I get the area of the rectangle? Well, wouldn't it be length times width down here? Length times width. And I do that, I get the area of one base. But how many of these bases do I have? 2. So that's where this formula comes out. Hopefully that makes sense. Okay, next one over here. Well, let's, what's this situation? Let me come in here to volume. Okay, so the big B says to get the area of the base. How do I get the area of my base? Length times width. So when I do that, I get a bunch of squares on the base. Now, when I multiply times the height, it fills it up with a whole bunch of other squares. Okay. Another one. A whole bunch of squares. When I multiply times height, now I'm filling it up with the cubes. When I stack another square on top of another square, basically, I'm filling it up with cubes. I'm filling it up with these 3-dimensional things. Well, I thought you said a while ago, sir, there was 3 dimensionals. Yes, well, your base is your length times your width times my height. There's my length, width, and height, making it 3-dimensional. Okay, now let's come over here real quick. This L, have you ever seen the L? Is your slant height. Okay, well, what do you mean? So I'm just going to show you a side profile of this Okay, so imagine I'm looking at this pyramid on the side. You see this distance here would be your slant height. Your height of your pyramid would be going straight up and down perpendicular to the floor. You can even look at the height of your pyramid being over here, like right on perpendicular to the floor. This is your slant height. How do you find your slant height? It's usually given to you. Okay, it's not too bad. It's going to be given to you. So look at the formula. It says 1/2 times the perimeter. What's the P stand for? Perimeter of my base. So you get the perimeter of the base times your slant height times that number. So that gives you all the sides. Okay, it gives you all the sides. Lateral surface area. And then this one says, well, now you need to add up the base, the area of the base. Okay, volume. I want to show you something cool about a volume of this thing here and this thing here. So if I imagine this rectangular prism, right? And then I had a pyramid inside of it. That pyramid is 1/3 of that rectangular prism. What? So humor me, just bear with me. So imagine I could actually draw this prism, right? And now that pyramid is exactly inside of a prism, right? That pyramid is exactly inside that prism. That pyramid is 1/3 the height. I'm sorry, 1/3 the volume of the whole prism. That pyramid is 1/3 of it. So you look at this cone real quick. That cone, if you think about it, it fits inside of a cylinder. That cone is 1/3 the volume of that cylinder. So I'll give you one more example. Imagine I had this cone inside this cylinder. That cone is 1/3 the volume of that cylinder. Or you want to look at the other way, that cylinder is 3 times the amount of that cone. Let's come back over here. These are the easiest ones, I think, to work with. The only bad thing about these are pies, because people don't like pi. I'm just saying that's just the only issue. Because if you look at this, all you need to find is your R. There it is. It's usually given to you. It has to be given to you. And your H. That's it. R and H. Here you just need your R. Plug it in the calculator and you got your answer. Pretty easy. It's not too bad. For the volume, all you need is your R and your H. R, don't forget, is your radius. Height is there. Same thing over here. For the surface area, numbers, again, you don't need to memorize these things. Basically, all you need to do is just go back and refer to them. Slash you should have them in your notes. Radius here. Radius is given to you. Length, or L, is slant height. Plus pi, radius squared. Where's radius squared? My radius. And that's it. For the volume, is going to need R and H. This was the easiest one ever, because all you need to do is plug in the R. So it's 4 times pi times R squared. This volume is just as easy. 4/3 times pi. That's going to be constant. All you need to find is your R. Okay, not too bad. Let's practice them or what? Please, God, let's practice them. Ooh. Oh, wow. Lordy, lordy, lordy. What's going on here? Okay, so let's find the surface area and volume of the square pyramid. Okay, so let's come out here. Surface area, find the formula. Where's surface area? So this is the formula we're going to use. Find the volume. We're going to use these 2 formulas. And that's it. So you come back over here and plug in the numbers. So there's a formula right here. 1/2 is 1/2. Perimeter, P stands for perimeter of your base. So you go to your base, find the perimeter of it. Since it says it's a square pyramid, I know it's a 6. That backside is 6. That's 6, and that's 6. So there's your 24. Your slant height is the distance, okay, that the triangle is lying down. That lying downness. There's my 5. Your B, what does big B stand for? Area of your base. So get the area of your base. How do you get the area of a square? 6 times 6, which is what? 36. Punch that in the calculator. There's your answer. Okay, remember this was your surface area. Volume now, this is 1/3 right there, base times height. So volume, we can do this real quick, then I'll move the book up. Look at this, 1/3. Now big B stands for area of your base. My base is this, what was it again? Square. Oh, so it's a 6 by 6, right? So it's 1/3, 36. H. Remember H. H is your height of your pyramid. How far is it from here to here? How tall is that thing? How tall is this thing? Or you find it in here. 4. Make sense? The reason we used this 5 right now a while ago, because this is the L, the slant height. This is the height of your whole figure. So we're going to come out here. I can't do that work in my head. Where is it? There it is. 1/3, 36 times 4. Actually, we could do 1/3 of 36, right? Which is 12. 12 times 4, 48. Let's practice. Ooh, which one do you want to practice? Okay, let's do the cylinder. You have to refer to your formula that says go. Okay, find the surface area and the volume. Let's look at that. Surface area and volume. Where are we at? So right here, surface area. I'm going to put FA surface area. I believe the formula is 2 pi r h. Plus 2 pi radius squared. Okay? And that's it. So all we need is a 2. The 2 is right there. But boom. Pi is right here. Pi. My radius. You all know what my radius is? 6. Good job. Not everybody at once. I appreciate it. 6. Height. What's my height of this thing? So the height is the distance from one base to the other base. 18. Plus this right here comes down. 2 pi. And then 6 squared. Okay. So let's do everything, if you don't mind. Everything, but don't multiply by pi. Okay. So let's multiply 2 times 6 times 18. This is an 8th grade answer / you are responsible for this. So on the calculator, I'm going to multiply 2 times 6 times 18. That gives me 216. Pay attention here, guys. When I multiply 2 times 6 times 18, it gives me 216. What haven't I multiplied by? So I'm bringing that down. All right. Plus, well, this one right here is 36. 36 times 2 is 72. All right. I'm going to tell you this because this is a possible answer right here. What do you mean? Well, look, if I have 216 pi here and I have another 72 pi here, well, what do you have? 288 pi? Boom. Make sense? Don't I have 288 pi? That's my best answer. That's my exact answer. This is exact. So boom, that's the best one right there. That could be an answer in your S choices. Your approximate answer. Now we can go to multiply it. 288 times pi. Approximately 904 779. Whoa, 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 whoa. Was that just the surface area? Yeah, that was pretty easy, no? Pretty easy, pretty cheesy. Guys, guess what it is? Friday. It's also the end of my period. Have a good day. We'll see y'all. Bye-bye, Eileen. Thank you so much for participating.
Bye.
Bye-bye, Diego. All right, have a good weekend, guys. Be safe.
Bye.
Bye-bye. Thank you so much for participating, everybody. Ricardo, glad you could join us again, brother. Bye-bye. We'll see you, brother. Bye-bye, Daniela. Have a good weekend.